to router 3. However, router 3 doesn't know how to get back to router 1 because it sees the destination here. You know, the source of the pings here are, you know, the 12 network. However, router 3, if I do a show IP route, it has no idea about the 12 network because that's in the OSPF domain. So again, single redistribution in this example is not going to work when I try to ping here to a network, an EIGRP network, even though it shows up in a routing table. You know, this is not going to be adequate enough for this to work. As you can see, we're getting unroutable messages when we do a debug IP packet. And that's because our local router here on router 3 does not know how to get to the 12 network. And as you might have already been asking yourself, okay, I can understand why these EIGRP routes have been redistributed into OSPF. You know, what's up with the E2? E2 is for external type 2. So these routes are coming in to router 1 as OSPF external type 2 routes, and that is the default when redistribution is done from a protocol outside of OSPF into OSPF. They come in as external type 2 routes with a metric of or what this means is that this metric, no matter how many routers we have in our OSPF domain here, say we have 10 routers behind router 1, these routes that are coming in as external type 2s, what that means is the metric, which is 20 in this case, will never change. And you can change this behavior. You can set, you know, the metric to external type 1, and what that's going to mean is the metric is going to increment based upon, you know, the best path through the network and what all the bandwidth settings are, and you know how OSPF calculates its metrics. So external type 2, it's just going to stay the same. External type 1 means that it's going to be incrementing throughout the network. Also here, what we're seeing, and a lot of you might be saying, you know, how is this network being advertised? Because, you know, from router 2's perspective, this network here, this 23 network, we're not seeing as an EIGRP learned network. And this is a very important rule within redistribution that everybody needs to know, because it's vital to the success of, you know, redistribution and learning redistribution. And that is, when we redistribute, you know, these EIGRP routes into OSPF, what also goes on in the background is that all the networks that we have EIGRP running on, in this case, if I do a show IP protocols here, and we look at EIGRP, you know, which says here we're routing for networks 172.16.23.2. Well, this network is going to be sent down as well into the redistribution process. So that is why router 1 is seeing this network here. And this is very important to learning redistribution, because if you don't know what's going on in the background, and again, this, you know, doesn't show up when you do a show run, you know, it's not going to show this network being, you know, advertised into the redistribution process to R1. So it's like the router is creating this on its own in the background, but it's very important that you realize that this is happening, because it's like it's making a route map, and it's, you know, it's matching these networks that we're routing for inside the EIGRP process. So let's go ahead and do redistribution between, on router 2, let's do redistribution from OSPF routes into EIGRP. I don't know if we tried to ping. Let's go ahead and try to ping real fast here. Actually, you know what? No, we already did that, and I already explained all that. Never mind. Let's go ahead here into router 2. We'll go ahead and do a router EIGRP 1. And then we'll follow that up with the redistribute. And then we'll do OSPF. And then our process ID here is 1. And if we go ahead and just hit enter here, I'm going to show you guys another mistake that people make here when they're redistributing, from, protocols into EIGRP. If we just leave it like this with redistribute OSPF 1, if we go to router 3 and do a show IP route, as you can see, we are not learning of the OSPF routes within the EIGRP domain yet. And that is because we have to specify within EIGRP, we have to specify a metric. Because if we do not do this, then the redistribution process will fail. Also, you can specify within, EIGRP, we could do a default metric, and just, of course you're not going to do all ones, but in this example, we can just do all ones here. Now, all ones are what this is, these are the K values. So it goes through, all the K values: bandwidth, delay, reliability, load, and of course MTU. So we can go ahead and just specify a default metric here, and now what we see here is we see these routes come in, and they're just going to have the default metric which we specified here. They're going to take this default metric into, consideration. The other way you can do this, of course, let's go ahead and back out of this. Let's do a no default metric. Make sure those routes aren't being seen anymore, as they are not. And then if we just go ahead and do a redistribute OSPF and then metric command here, and then the same thing, the 5K values. So we'll go ahead and, to keep it simple in this scenario, we'll just do all ones here, which, in the real world or in, a test environment, you're not going to want to do that.